Hello, and welcome back to our discussion on area between curves. So we're going to continue for example, number 5. Now for number 5, we are looking at the area bounded between the cosine of x function and y equals 1/2. Now the first thing I notice is, again, we're in terms of x. So let me write this down. We are definitely in terms of x, and that is just telling us we are using a vertical rectangle. So when we draw this, we're only looking at from 0 to pi over 3. So when I draw this, the cosine of x looks like this, looks like so. And we're going to go from 0 to pi over 3. And we're also looking at the line y equals 1/2. So we're going to be above there, right there. When we shade in the region, this is the region we're looking for because we're looking for the region bounded by those two curves. Draw your rectangle of mathematics somewhere in the middle there. There we go. And I'm going to blow it up. There's my rectangle of math. The skinny part, there's my dx down here. There's my skinny part. It's horizontal, so that's going to be dx, and we just have to get the length again. Now the length, because we are vertical, again, is top minus the bottom. We're going to use this a lot throughout this whole unit, so get used to that. The top is our cosine curve, and the bottom is our line y equals 1/2. And so if I want to find the area of this one tiny little rectangle that we have, we're going to take the dx and multiply it by the length. The width, multiply it by its length. So that's going to give us cosine of x minus 1/2 times dx. And we're going to evaluate that. Now, they tell us the domain is 0 to pi over 3, so that's cool for us. Take the antiderivative, so that's going to become sine of x minus 1/2 x from 0 to pi over 3. And using the FTC here, f of pi over 3 minus f of 0. Plugging in, we get the sine of pi over 3 minus 1/2 times pi over 3. Plug in 0, sine of 0 minus just 0. Now, sine of 0 is just 0, so that's good. So we just need the sine of pi over 3, which is root 3 over 2 minus pi over 6. And there's our area. Don't forget, you cannot leave it as pi over sine of pi over 3. All right, let's see. Oh, look, here's another one. So here's a question for you then. What would happen? Sorry, fly out here bothering me. What would happen if we want to find the area bounded by the following two functions, f and g? Now, if you notice here, we have this region in between, but they meet here. So there we go. Now, if we were to set this up, right here, we'd have to make two rectangles of mathematics. So the first rectangle of mathematics is still dx then, but the top function is g of x. So it's going to be g of x minus the bottom, which is f of x. To get the area of that one rectangle, we would be g of x minus, that's a weird looking f, minus f of x dx. But then we have this other rectangle that we talked about as well. So let's go ahead and set that one up as well. I just do two rectangles of mathematics, dx thick, and here on top is f of x minus, and the bottom, of course, is g of x. Notice we just switched places. For the first one, it was g minus f, and here's f minus g. When we set it up, we would get this area would be f of x minus g of x dx, and we're going to add those together. The only thing we need now are the bounds. So we're not really told anything about the bounds, so we're going to make it up. We'll call this A, B, and they meet here at C. So the first one we go from A to B, and the second one we go from B to C. All right, so I hope, and we would solve this, of course. So I hope you enjoyed this video. We have more examples and some practice problems at home, so make sure you try those out. I'll see you soon. Bye-bye.